All right, welcome ladies and gentlemen to the last section of chapter 8. This is three-dimensional Cartesian coordinate system. So if you haven't seen this word yet, the word Cartesian, you should have seen it by now, just means our normal x, y, z's, and all that sort of fun stuff. It's just named after a guy named Rene Descartes. Just gets his name tagged on there. So what we're going to be doing is graphing and calculating things in 3 dimensions. Things we already know how to do, like distance, equations of circles, some vectors in 3 dimensions, that sort of interesting ideas here. Okay, so first of all, graphing coordinates and planes. Oops. Graphing coordinates and planes. So if I was to give you a coordinate, points are in the form x, y, z. We're going to go in the x direction, the y direction, and the z direction. If you were to graph the x, y, z space, what you might think of as the vertical is really the up and down axis. This is the z axis. This is kind of the standard way to draw this, by the way. This is the y-axis, so it gets you a little bit confused here. And the z, or the x direction, kind of goes towards you and away from you in this fashion here. It goes away from you, so you have to think of this as a third dimension. It's not just up and down, it's left and right and forward and backwards. So this is the positive y-axis, the positive z-axis, and back here is or up here is the positive x-axis. This is the negative, and the negative. So if I was to give you the coordinate 1, 3, and -2, here's what you basically need to do. Let's change my pen here to, let's just go blue. I need to go 1 unit in the x direction, the positive x direction. So let's say this is about 1. I need to go 3 units. Oh, what happened there? 3 units in the y direction. So there would be like a 1. Come on. 2, and a 3, and then down 2. So down 2. So I go x direction 1, 3 units in the y, and then down 2 units. This, let's call this coordinate A. There would be A. Now, it is kind of hard to see the fact that we are drawing a 3-dimensional dot on a 2-dimensional space called this screen, but we've gone 1 in the x direction, 3 in the y direction, and then down 2 units. And if you need a physical representation of this, I can show you one. I kind of use textbooks and that sort of idea in order to do this. Or you can try to look at the examples in the textbook, because they use computer technology where my hand-drawn stuff is only so good. One of the things that you might notice here is normally in graphing in 2 dimensions, we get quadrants because it breaks up the plane into 4 pieces. In this, we actually get what are called octants because the 3 axes actually break it up into 8 equal sections. So we get 8 octants. So we can be an octant 1, 2, 3, 4, 5, 6, 7, 8. We're not going to define them, really. We don't really need to. So use the axis direction. So I just gave you the directions, right? Positive, negative, positive, negative, positive, negative. If we were to graph a plane like this, normally we graph lines where the z doesn't exist. And we would graph 2x plus 4y equals 8. If we were to just graph 2x plus 4y equals 8, I would find the 2 intercepts. I'd find the x-intercept and the y-intercept, plot those 2 dots, and connect the 2 dots. So in 3 dimensions, we do kind of the same thing. What we're going to do is we're going to find the x, y, and z intercepts. So if I let x equals 0 and y equals 0, z equals -8. So we plot that -8. If x equals 0 and z equals 0, y is +2. This is not drawn to scale. And the same thing, if y and z are 0, x is 4. And then what we do is we connect the dots into a triangle and shade, because this is actually a representation of a plane. P-L-A-N-E, they kind of like a piece of paper is a plane object. And you could try to draw a plane there, but it's really actually kind of hard. It's a little bit easier to draw the triangle representation. All right, so that's the basics of three-dimensional drawing. Most everything is basically stuff we already know how to do. If we were to find distance and midpoint, so finding the distance between 2 points, you know to use the distance formula. Well, the distance formula is a big square root. And if we were only in 2 dimensions, remember this is the distance between 2 points. So it's like an x1, y1, z1, x1, y2, z2. If we were only 2 dimensions, we would do, okay, x2 minus x1 squared plus y2 minus y1 squared. But we're in 3 dimensions, so let's add another one. Really simple. That's the distance formula. The distance between any 2 points in 3 dimensions. And it goes the same for midpoint. Midpoint is just a big coordinate where we find the average of the 2 values. Well, in this case, we have 3 different things. So we're going to take, okay, the average of the x coordinates, the average of the y coordinates, and the average of the z coordinates. It's as easy as that. Those are really that simple. I may have mentioned this was going to be a short video. Well, the equation of a sphere goes right along with what we know for a circle. A sphere is just a 3-dimensional circle. A circle that's been spun around an axis and is created a 3-dimensional object. Well, we know that the equations of a sphere with center HK. Okay, so we know we would say, okay, it's x minus h squared plus y minus k squared equals the radius squared. But I left a big spot there because we have something extra. The textbook uses an L, so I'll go ahead and use an L as well. So this is with center H, K, L. Notice I'm using a cursive L because regular L's look like 1s. So Z minus L squared. There you go. That's the equation of a sphere with center HKL and radius R. Let's write that here. Radius R. Just so you have it somewhere. Nothing to do with actually this lesson, but it might be a good thing to know. Volume of a sphere is 4/3 pi r cubed. Just a good formula to know, by the way. Moving forward, we have our new stuff with vectors. So, a couple things here. Vectors still deal the same way that they dealt in our last chapter. And vectors are just now in the form of x, y, z, so we can go in 3 different directions. You always find a vector like this when I tell you to find the vector from 1, 3, 7 2, 7, negative 2, 6, I need to do, so this is my initial, this is my terminal. So I need to do terminal minus initial to get the vector of 7 minus 1 is 6, negative 2 minus 3 is negative 5, and 6 minus 7 is negative 1. That is the vector going from initial to terminal. Dot product is exactly the same. Magnitude, we already technically found magnitude, is, let's say I was given this vector x, y, z and given another vector as, I don't know, a, b, c. If I found the dot product of those two things, if I did v dot w, that's equal to ax plus by plus cz. So I'm multiplying the three components together and then adding them together to get a constant, to get a single number. The magnitude of v, if you got to remember those straight bars, not absolute value technically, magnitude is equal to the square root of the x coordinate squared, oops, no comma there, plus the y coordinate squared plus the z coordinate squared. Nice and simple. And looky there, we've reached the finish of this lesson, or of this video. Here's your assignment, though most of you should have written that down already. If you have questions, let me know so we can go over it. I will mention that this is not a huge part of the test coming up at the end of the week. The majority of the test, 99% of the test, will be 8.1, 8.2, 8.3, and 8.5. So make sure you know how to do all four of those sections as you move forward. You guys can start the review assignment, choose whatever things you need to review, redo the quiz, whatever you guys need to do. Not for score, just redo it as practice. That's what I mean. All right, I will see you guys later.